Hello class 9. Today our topic in this chapter is physical and chemical changes. Physical and chemical changes. Now what is a physical change? From the name only we can make out physical change means a change in which only physical state of substance is changing. Otherwise everything else will remain the same. Physical change. A change in which no new substance is formed. But physical state of the substance changes, and the product that is forming, that is chemically identical. The product is chemically identical to the starting material. To the starting substance, but it differ in physical characteristics. Physical characteristics means it's solid, liquid, or it is in a gaseous state. Physical characteristics, they are different, but chemically this compound will be same only. Now to understand what is physical change, I am taking one example. Example is evaporation of water. Or we can take example ice melting of ice. So see, when the ice melts, we are taking ice, for example this is ice, and on heating this ice, what happens? This ice will start melting and it will change to a water which is in a liquid state. So no new substance is forming. How no new substance is forming? Because this is also water and this is also water. So chemically its formula is H2O, and formula of this compound is also H2O. This is also made up of hydrogen and oxygen, and this is also made up of hydrogen and oxygen. So no new substance is forming, but physical state is different. This is in a solid state, this is in a liquid state. So product is chemically identical to the starting substance. Chemically they are identical, but they differ in physical characteristics, that is this is solid and this is in a liquid state. This is the meaning of a physical change. Now, what are the characteristics that we'll see in a physical change? One is this is temporary. Temporary means it can be reversed easily. It can be easily changed back to the original form. We can change this liquid to ice just by lowering down the temperature. This will change back to this original form. So this is temporary, or you can say we can easily reverse this change. So this is what is a physical change. After knowing what is a physical change, we are moving on to the next part, chemical change. Now what is a chemical change? A change in which one or more substances, they undergo a change to form a new substance. Chemical change. A change in which one or more substances, they undergo a change and they are forming a new substance. So whenever a new substance is formed, that change is known as a chemical change. In this type of change, the original substance lose their identity, like we have done that mixture and compound topic last time. So here in this change, the original substance is losing their identity and gets converted into a new substance. So this new substance will not show the characteristics of these substances from which it is forming. The new substances formed cannot be converted back to these easily. They can be converted but not easily by physical process. And chemical changes characteristics are, these are permanent, because easily we cannot change them back to the original form. So these are permanent, or we can say that these are irreversible in nature. We cannot reverse them easily to the original form. To understand this, we are taking an example. Let's take a magnesium ribbon and burn it. That means if we are burning it, magnesium is actually reacting with air, and it is reacting with oxygen present in an air. And when we are burning this, it emits a bright white light. A bright white light is emitted, and this changes to a white color powder. That is because a new substance is forming here, that is magnesium oxide. We had taken magnesium and oxygen, but entirely new substance is formed here, that is magnesium oxide. This is new substance formed here. And remember, this is the form of a white powder. Thus, burning of magnesium ribbon is a chemical change. Some more examples of this: burning of paper, burning of everything actually comes under a chemical change. Burning of a paper, burning of wood we can take, cooking of food, rusting of iron. All these are examples of a chemical change. All these are chemical changes. So this is about topic physical and chemical changes, and afterwards we'll do some examples to identify that this comes under a physical change or a chemical change. Moving on to the next topic now after this is solutions. What is a solution? It is a homogeneous mixture. Homogeneous means uniform. Last time we did the mixture types, homogeneous and heterogeneous mixtures, and we have done that solutions, they come under homogeneous mixtures of two or more. After this, see what I'm writing. Chemically non-reacting substances. In mixture, the components, they are non-reacting. They do not react in the form of a mixture. Then it is called a solution. So homogeneous mixture of two or more chemically non-reacting substances is called a solution. Next we have components of a solution. Since we have done that it's a mixture of two or more chemically non-reacting substances, so there are so many components in a solution, but we are restricting our topic only to binary solutions. Binary solutions means we are just taking two components in a solution. One component in this solution is a solute, and the other one we are taking is a solvent. Now, what is a solute? It is a component of solution which gets dissolved in a medium. In something it gets dissolved, and we can say is present in smaller amount. In smaller amount is a solute. So what is a solvent? It is a component of the solution which is present in a larger amount and acts as a medium which dissolves the solute. In this, the solute will dissolve. Now, I'm taking an example for this thing. Let's take water in a beaker. We are taking water in this beaker. And to this water, we are adding some sugar. Some sugar we are adding from this. The sugar will go in this. But what will happen to this sugar? It will completely dissolve in this water. It will completely uniformly dissolve in this water. We cannot see the sugar particles separate in this water. So which kind of the mixture will get here? Homogeneous, because uniform mixing is there. So homogeneous. And then sugar that we are dissolving, the component that we are dissolving is a solute in which we dissolve the medium, that is a solvent. So water here is a solvent and sugar that we have taken is a solute in this case. So this is what is a solution. Now next, after this, we have types of solutions. Types of solutions. Now solutions are of different types, approximately 9 types of solutions we have. But the 9 types of solutions are based on the physical state of the solute and solvent. We are dividing the solutions into solid solutions, liquid solutions, and gaseous solutions. Now, what's the meaning of a solid solution? Solid solution means solvent here is solid. Liquid solution, solvent is liquid. And gaseous solutions means when solvent is in which state? Gaseous state. Now further, we can take the solute in a solid state, liquid, and in a gaseous state. So when we mix them together, how many type of the solutions we are getting here? Like I said, 9 types will be there. Name of solution, then solute in which physical state, solvent in which physical state, and example of these solutions. Now first I am taking up here solid solutions. Solid solutions. Solid solutions further are of 3 types. Solid, insolid, then liquid in solid, then we have gas in solid. This means solid in solid means both solute and solvent are in a solid state. Liquid in solid means solute is liquid and solvent is solid. Gas in liquid means solute is gas and solvent here is solid. So when solvent is solid, this comes under a solid solutions. Examples of these solutions, solid in solid example is alloys. Then liquid in solid is hydrated salts, the salts in which there is some amount of water, that is just water molecules are there. Gas in solid is gases adsorbed. Adsorbed means just they remain only on the surface. Adsorbed on the surface of metals. So this is the first category, that is a solid solutions. Next we have liquid solutions. Liquid solutions also are of 3 types, that is solid in liquid, then liquid in liquid, gas in liquid. And now the solute here is solid. This case it is liquid, here it is in a gaseous state, while solvent in all three cases is in a liquid form. Examples of these solutions are solid in liquid, the normal solutions that we study like salt in water, sugar in water, copper sulfate in water. These are examples of solid in liquid solution. Liquid in liquid, miscible liquids like alcohol in water, acetone in water. Gas in liquid is aerated drinks, the soft drinks, where gas is dissolved in a liquid. Now coming to the third category of solutions, gaseous solutions. These are also three types: solid in gas, liquid in gas, and gas in gas. Solute is solid here, liquid in this case it is in a gaseous form, while solvent in all three cases is in a gaseous form. Example, solid in gas like iodine vapors in air or camphor in air. Liquid in gas is clouds, fog, and gas in gases example is air. Air has the oxygen, nitrogen, all these gases are there in air. So gas in gas. So total how many type of solutions we have? 9 type of solutions based on the physical state of solute and solvent. We have divided these solutions. So now properties of these solutions. What characteristics these solutions they show? Properties of solutions. Like first characteristic that we have done is that solutions are homogeneous. Solutions always they are homogeneous in nature. Next is that particle size, that is solute. When we say particle, that means we are talking about solute particles. Solute particles in case of solutions are very small. Because they're very small in size, approximately 1 nanometer is their size. And because the size is very small, so they can pass through a filter paper. So we cannot separate the solute from solvent by doing the filtration in this case. Then particles of solution here in this case, we call these solutions actually as true solutions. Remember, when we are talking about solution means actually we are talking about true solutions. They do not show Tyndall effect. This property is not shown by these solutions. Now question here is, what is a Tyndall effect? Tyndall effect means when we take a true solution like salt dissolved in water or copper sulfate dissolved in water, if these true solutions are taken and from this side if we are throwing a light on this solution, and this has to be kept in a dark room through a, you can say, torch. When we are throwing a light on this, if the light will scatter like this, like a cone, and this is of blue color, then that is known as Tyndall effect. But this solution is not a true solution, so this scattering of light is not taking place here. If it will scatter like this, then that property is known as Tyndall effect. In case of true solutions, actually what happens is, when light is passed through the solution, it just passes straight. No scattering of light takes place. No scattering of light. So if no scattering of light is there, that means the solution is a true solution. This is the characteristic of a true solution. Next property here, and they are stable. Stable means prepare the solution, dissolve the salt in water. It's not that after some time the salt will start separating out from the solvent. It will remain in that form only. That means this is stable. And one very important characteristic of true solutions is they are transparent. That means clearly from one side of the glass container, you can see through the other side of the container. The solutions, they are completely mixed up in the solvent. So the solution is transparent in nature. These are the properties of solutions. Moving on to the next topic, concentration of solutions. Whenever we are dealing with the solutions, we should know about this term concentration. What is the meaning of concentration? Concentration means amount of solute and solvent in the solution. Like if I'll ask you to prepare a solution of copper sulfate in water. Now some of you will take, for example, 100 ml water, some of you will take 200 ml of water. In that water, some of you will add 10 gram of the copper sulfate, some of you will add 100 gram of copper sulfate. You all have prepared a solution of copper sulfate in water, but how these solutions are different that you have prepared in the amount of solute and solvent. So if we'll say quantitatively we have to define this concentration, then what we can say is on the quantitative basis, quantitatively, the concentration of a solution is defined as the amount of solute present in the given amount of solution. In solution, how much is the amount of a solute? That is known as concentration. This is a definition of concentration of solution. In the given amount of solution, how much is the amount of a solute? But there are different ways to express this concentration, different ways to express concentration. And we are doing the two ways here to express concentration. The first one is mass percentage, or we can write mass by mass percentage. In solution, there are two things, solute and solvent. So what is the meaning of mass by mass percentage? Percentage means total solution is your 100 and it's by mass, that means total solution is 100 gram. In that 100 gram of solution, how much is the amount of solute in gram? That is called mass by mass percentage. So we will define this as mass of solute in grams, because it is percentage by mass. Mass of solute in grams present in 100 grams of the solution. And the formula to calculate this, there are numericals based on this thing. So mass percentage is equal to, here we'll write mass of solute upon mass of solution we will take here into 100. This is the formula to calculate the mass percentage of solute. Next one is volume by volume percentage. Now here also from this term only it's clear, we are taking the volume of the solute as well as that of the solution. From here only I'm defining, see, in place of mass, now we'll write volume. Volume of solute in milliliters present in 100 milliliter of the solution is called the percentage by volume. So here the definition is volume of solute in milliliters in 100 ml of solution. So now the formula for this is volume by volume percentage is equal to volume of solute taken in milliliter upon volume of solution, this also should be in milliliter, into 100. This is how we'll calculate the mass percentage and volume by volume percentage. Next topic for today is saturated and unsaturated solutions. What are saturated solutions and what are unsaturated solutions? Saturated solution, from the name again, saturated, it does not have a capacity to take more solute in it. A solution in which no more solute can dissolve. No more solute can be dissolved. But remember, at a given temperature, because if the temperature will change, then the solubility will change. This type of solution is known as saturated solution. Now from this only we can write a definition of unsaturated solutions. Now which solution is unsaturated? In which some amount of solute can be dissolved, in which more of the solute can be dissolved at a given temperature, is called unsaturated solution. So now we have solubility. Before this we have done concentration. Now it is solubility. See the difference now in the concentration and solubility. When we have saturated solution, then only we'll define solubility. That means we have dissolved the solute in a solvent, but no more solute can dissolve now. So what is solubility? It is the maximum amount, after this no more solute can dissolve. It is the maximum amount of the solute that can dissolve in 100 gram of, see what I'm writing, 100 gram of solvent here I'm writing, and there we wrote solution at a given temperature, solvent at a given temperature and pressure also, because if temperature and pressure will change, solubility will change. So now see the difference from concentration. Here one word is extra, maximum amount. There we wrote it is the amount of solute that can dissolve in 100 gram of solution, and here we're writing 100 gram of solvent at a given temperature and pressure. For example, if we take salt, common salt that we use in our kitchens, which is called sodium chloride, it can dissolve in water 36 gram at 20 degrees Celsius. Maximum how much amount can dissolve? 36 gram can dissolve at 20 degrees Celsius. So one thing more now here, effect of temperature on this solubility. We are writing with the definition at a given temperature. At this temperature, this is a solubility. So what is the role of temperature here? A solution which is saturated at a particular temperature, when we increase its temperature, its solubility will increase. Solubility increases with increase in temperature, and solubility decreases with decrease in temperature. So if in place of 20 degrees Celsius, the temperature will be 30 degrees Celsius, some more salt can be dissolved here. And if temperature is 10 degrees Celsius, we are decreasing the temperature, this amount will decrease. So with increase in temperature, solubility increases. With decrease in temperature, solubility decreases. This is what we have in our today's lecture. Thank you.